Welcome everybody to the KMC monthly series in what we call the 2025 Lunch and Learn Remote Monthly Learning Webinar Series. And we do our very best to attract the most distinguished panelists from all over the globe with one simple goal in mind, which is we want to collaborate in the most objective way with owners and operators of corporate and commercial real estate and even government real estate to achieve the very best tenant experiences, as what I hear many times called a frictionless tenant experience that causes the highest workplace productivity, the greatest comfort, the greatest sense of well-being, cyber operational resilience, ESG compliance, all that, of course, with the highest ROI. So those are all the general goals for each of these series. We do them on the third Friday of each month. So today, the 20th of June, we're doing our next on the 25th of June. July 25th, Friday. It will be for a whole different topic we'll get into later. But for now, I want to bookend this conversation with first the title, then some introductions. We'll get into some Q&A between the panelists. We'll do some hopeful interaction with you in the audience. Anything on your mind with respect to this topic. We'll do our very best to curate those questions. And finally, at the very end, we'll try to go highlight for what's coming up next. So today, to begin, my name is Ari Reubin. I lead what is called KMC Consulting. We are a division of KMC Controls. And we have with us, we have the Dean at the Carnegie Mellon College of Civil Engineering. We have the CEO of Alosonar. We have the CEO of Boom Interactive, and we have the CEO of Boom Real Estate Advisors. Why this group? It's a very unique group, and you'll see when we start going through the intros and into the Q&A, is because we're talking about AI-powered digital twins and the use of these really powerful engines to do 3D modeling of floor plans and other environments, other built environments, to provide a unified IoT platform, and to do that, again, as accelerants of peak experience for tenants mostly, but then, of course, landlords and employees. So the open questions are, what are the best practices? What, if any, are barriers to adoption? How does this help achieve any kind of goals that we have above for these peak experiences? So I first want to go around and make the introduction. I think in many respects, I want to start with you, Professor. So please introduce yourself kindly and maybe give a little bit of a, not so much a short introduction, but this goes to all of you, but why do you do what you do? Why is this your passion? Why is this your calling? And in particular, center us on this topic. What are you expecting to learn today?
Sounds good, Ari. So good morning or good afternoon, everybody. This is Burcu Akinci. I'm not the dean. I'm department head. So I just wanted to clarify that. But thanks for the promotion. I'm the head of the Department of Civil and Environmental Engineering at Carnegie Mellon University. I'm also co-founder and Chief Innovation Officer of a startup called Lean FM Technologies that uses digital twins and AI. So I'm going to start with our department and why, I've been working in this digital twin space for a long period of time. Our department at Carnegie Mellon is fairly unique that we have a long history of embedding technology into the domain knowledge and domain decisions. So actually, this was one of the birthplaces of computer-aided engineering in 1970s. And since then, technology has been at the forefront and everything that we do. So digital twins and AI they're not no exception to this. So we have been kind of pushing the envelope on digital twin and AI side applied to civil engineering. Mostly looking at the operation phase and facility management phase for a while. The title of this session is AI-powered digital twin, But I also want to highlight that we come from the angle of not just AI-powered digital twin, but digital twin-powered AI. And I will tell what I mean by that. And why it kind of ties to the passion in this area. So when we look at our facilities and even our, specific pieces of equipment in our facilities, they behave very differently, depends on where they are kind of providing service to. Each facility is unique, that's not new to you, but even each component, even though same manufacturer, can behave very differently within the same facility. So with that as the background, right? So if I use a purely data-driven machine learning solution, then it's going to be very challenging to do the transfer learning. So it learns for one piece of equipment under certain conditions, but then transferring it to multiple pieces of equipment and multiple buildings is a challenge. So when you're in a space like that, like ours, where everything is unique, things change over time, users are deeply involved in the operations and override some of the controls even of what we do. When you're in a situation like that, context matters. And that's why digital twins are important, right? So when I mentioned the digital twin powered AI, I also see this component of digital twins providing the contextual information and data to empower, to make sure that the AI algorithms work the best for us. It's robust, they're robust, generalized, and scalable from that perspective. The other thing that I also want to highlight is that our definition of digital twin is very much aligned with the National Academy of Engineering's studies definition, where you do have a digital replica of the physical world, but it doesn't stay just being a replica. There's these bidirectional relationships between the physical world and the digital world. So it's not just the model, it's not a simulation model, it's not an information model, we call them models, right? It's also not just sensors being provided to a model, and now it becomes a digital twin because it's only one directional. And in that case,
Sure.
We call that digital shadow. So it shadows the physical world, but it's not like twin. It's not interacting with the physical world. It is actually this bidirectional. So the digital twin, composed of federated information models and simulation models, provides control and feedback to the physical world and change something to that. So when you have that interaction, a lot of powerful things can happen in terms of bringing much more autonomy into the physical world. Think about your cars being autonomous. Can we get buildings close to being your cars and having that autonomy, making right decisions in concert, of course, with the users and operators and the occupants. The other thing is also that is different in our domain is also the notion of human, right? The occupants. And I've heard Ari mentioning, one of your goals is to make sure the quality of life of the human occupying these facilities are important. So in our research, we also model the human behavior within the buildings as part of the digital twin, so that we can incorporate the preferences when we interact back to the
There'll be interaction effects. Let's this is probably a good natural point.
Sure.
I want to move on to, I call him the hybrid. He's a commercial real estate developer and architect. So Mark, why don't you pick up on riff off of what she's saying, and then of course introduce yourself.
Sure. So Mark Bulmash, Bulmash Real Estate Advisors. I also work with KMC Consulting. So for 37 years, I developed a wide range of commercial real estate, starting with retail and ultimately getting into mixed use and master plan projects and districts and so forth. And the interesting thing is in my architecture training, I was among the last classes that learned how to draw projects, right? just after me within a few years, and I went to a very technical architecture school at the University of Michigan. There was the introduction to CAD, and all the kids started learning CAD design and so forth. So I've always embraced technology, but unfortunately I didn't start there. But it informs me because when I became a developer, I was with various companies that tried to be cutting edge with technology, but during the ideation process of trying to figure out what it was that you wanted to plan, what was the vision and so forth, I became increasingly frustrated with architects and planners who couldn't draw, right? They couldn't think during brainstorming sessions, right? They needed tools that could help them. And many of the CAD people, it was like, well, let me get back to you, right, in a few days or a few weeks. And it kind of lost that synergistic part of the process where the owner developer is working with the designer and developing ideas in real time. And one of the interesting things at Howard Hughes, we were exploring exporting plans and using augmented reality to start introducing tenants to what is the view going to look like outside of 110 North Wacker in this super high technology building. What's that corner view going to look like? Because we had combined kind of drone photography, 360 photography with our plans. And anyway, what I ultimately was doing as I was working with projects is I had to work with talented architects and planners who could sketch ideas at that time. And BIM and even SketchUp didn't give that real-time working through ideas early on in the process. And now I'm excited. I think that there are some things out there that you're going to hear about where we can start talking about these things in real time. And look, back early on in my career as an architect, I can remember physically measuring existing buildings, right? So that we could do as-builts because there weren't any available so that we could begin to do projects. Now you can kind of do it like that. And we'll see a very fascinating product by Boom that allows people to do things that used to take us weeks to get to. Now it can take us, minutes, seconds, whatever the case may be. So very excited about the topic.
Thank you, Mark. This is really a nice way to lead off. I'd like to, just as a heads up, we're having some technical difficulties with one of our presenters, and we're trying to resolve that. So, but you would normally see one more face. But let's go to Emmanuel, and not because I'm of any other reason, but I want to go to you, Emmanuel. You have the nicest glasses of anyone on the screen.
Oh, thank you.
Please introduce yourself, your passion, your history, all this. I want to hear you preach it.
Perfect. Thank you, Ari, and good morning, good afternoon, good evening, everybody. My name is Emmanuel Daniel, CEO and founder of Alosner. Alosner focuses predominantly on data centers, smart building, and human experience consulting and design. I opened Alosner to help drive how human experience could merge with physical infrastructure, and how experiences and physical infrastructure could interact, and how one could shape the other. Where the whole philosophy was, how do you create a space where the space works for the human, and thereby empowering the human to be a much more productive version of themselves. Therefore, in that space, the human can aspire to be what they want to be, and they can achieve it successfully because the space responds to each of their needs. Prior to founding Alosner, I worked at Microsoft for a number of years, had a bunch of roles. Most recently, the one I left Microsoft was I was part of the data center group, where I was the lead for digitization. How do you digitize the construction and build of data centers? And prior to that, I was with their real estate and facilities group, where I was the global head of smart buildings and oversaw digitization of Microsoft's buildings across the globe. What that eventually meant is, how do we get people who come into our spaces, offices, to be able to interact with the space, with the technology, with the surroundings, and thereby help them to become more productive. And that's where my passion actually started. A passion for me was always around how am I going to make this space exciting enough so that a human would like to come and occupy that space. It is never about, hey, what does a human have to do? But the fact is, how is the space going to respond to the various needs of each individual that comes into contact within that space? To design a space of that capability, of that category, we will have to model it, we will have to simulate it, we'll have to put in various parameters that every human responds to differently. And that's where the whole concept of the digital twin came in. In fact, when I was a part of Microsoft, I ended up building a platform which eventually became the world's second largest twin in terms of how many objects we have to twin, because that was the only way we could model and simulate the amount of data that is needed to be able to enhance human experiences as we're able to move forward. So with the whole concept of a twin, why is that important? Twins form the foundation of how we're able to simulate real life experiences in a controlled manner, catering and modeling to different human behaviors. If I have to do that in a live environment, you could imagine how long that will take and how unfeasible that would be. The second aspect of it is for me, when I'm driving these engagements and talking to customers, either be it a data center, a building, or a city, the most important aspect that we all try to understand is, how are you able to ensure the physical space and the infrastructure tied to that space is not something that is just designed for one point or one mode of use. The twin allows us to do dynamic modeling of that space and of the interactions in that space, so we can actually move from static design to predictive design to prescriptive design, where depending upon who occupies that space, the space will be able to adapt and change its parameters and settings, so that person would be able to carry out what they want to do. And the classical example that I would give is, if me as an individual, okay, I have a very specific work style, very specific parameters and set of conditions that make me feel comfortable. There are times where I love to be in a crowd. There are times where I like to be alone. There are times where I like to have a lot of noise, and there are times where, I like to be peace and quiet. How is that space going to know what my requirements are? And why should that space be unique to my home, to my office, or to a coffee shop, or to a place in the park? What if I could take my personal preferences with me? And depending upon what I'm looking to achieve, that space, I'm able to ask that space to be able to dynamically change itself so that I'm able to accomplish all these tasks. And that's where the ability of a twin starts to come in, where people view a twin as a design time tool. But for me, twin also serves as an operations times tool, where through these parameters, I'm able to simulate the environment. And based on the twin, I'm able to then authenticate and have the physical environment adapt to the simulation that have been created. That's why for me, in my line of work, both as the CEO of Alosner and working at Microsoft previously, the twin formed the foundation of how we design and operationalize all of the experiences within that physical space.
Emmanuel, this is a perfect stop point, because I want to come back to that. And I think you've also drawn the battle lines, as far as I'm concerned, for this call, like what is and what is not a twin, or what was it intended to be in a twin versus shadow. All these things I think are delicious. So let's consume them one at a time. Next, please, Timber, would you kindly introduce yourself, and then after you talk about who you are and what you've done, let's quickly go into a demo where you can transform a floor plan into a 3D model. Reasonable?
That is reasonable, yes. I apologize for the technical difficulties. I swear I'm a tech guy. I have a background in it, and for some reason, Zoom is like the bane of my existence right now. But appreciate.
Please go. Yeah.
Yes, appreciate you having me on. Thank you to all of you. Sky, Ari, thank you. Emmanuel, thank you. Mark, good to see you again. So my name is Timber Barker. I am the CEO founder. Boom Interactive. We're based out of Salt Lake City, Utah, and we build highly visual experiences using AI. And as you know, AI is kind of the big ticket item these days, but we've been building AI for a very long time. Specifically, this platform called CoreSpec 3D over the last 6 years. And, you know, kind of piggybacking off what Emmanuel and the team has said here is digital twins have evolved. The word digital twin's been around a really long time, but it has evolved quite a bit, actually. I've written recently on the future of digital twins and how it needs to be exactly what Emmanuel just said. It has to be interactive, it has to be shareable, it has to be accessible. For the longest time, it isn't accessible. So we set out to make the hero, which we believe is the floor plan of every building. That's the hero. So if that's the hero, it needs to be accessible, updatable, interactable. And yes, these are words I'm making up on the fly. But it also has to support operations. So with all the amount of data now being poured into buildings, from your camera systems to your access control, HVAC, energy, other things like that, all of those coming into a building is, you know, there's a problem that we are also solving. Is let's pipe those all into a single system, so I have to sign into multiple systems and whatnot. So yes, Ari, I'd love to show the technology. I'm on my iPad right now. I'm just gonna share it on this, if that's okay.
Please.
And
it actually makes your message more powerful, because you show that you can do it on a phone, an iPad, a laptop, whatever.
Yeah, give me 1 second. I apologize. Let me sign into my account, and then I'll start sharing my screen.
And as he's doing this, I want everyone on the panel to please think about your point of view and the way you see things. And you know, the question I have, you know, top of mind is, you know, what's the standout success so far in your respective careers, either academic or entrepreneur or corporate, that kind of makes use of these kinds of technologies and tools. So I'm trying to stall for you, Timber.
Thank you. I will share screen with audio. Can everyone see that? Perfect. Okay, so 2 things out the gate. This had to work on every single device. So as I mentioned, I'm on my iPad right now, but this also works on my phone, whether Android or Apple, and it works on a Mac and also a PC. So that was the first thing we had to accomplish, because you can't make these accessible if you need a high-powered computer and it takes you many, many months to even just figure out how to use, you know, software. The future of software is accessible to everybody. The future of software is, again, for everyone. It's why we like software. So looking at this platform, what we've created is an image recognition AI that does its best to read walls, windows, and doors of just a photograph. So no one needs some special file format, and therein lies the simplicity of this. So in taking just an image of a floor plan, we have the ability, or our technology has the ability, to help you generate and create an instant 3D model of that floor. So let me remove some of these additional icons for a second, just to show you the core of it. This entire scene right here took me about 5 minutes to lay out. And the power of just saying that is massive. Now, it's not just a fancy visual, it's an extremely interactive piece of technology. So I can get my walls, windows, and my doors to the specificity I want to get me close enough. We want to help people get from 0 to 30 miles per hour faster than, I guess, a Tesla these days, right? So walls, windows, and doors, but what actually turns this into a communication platform, and that's how we actually describe this to a lot of our customers, is the ability to utilize these digital sticky notes. These digital sticky notes are what? They're decisions. So whether these decisions are a product decision or a maintenance issue, or hey, we need to really discuss something over here that has to do with, you know, people management or asset management, very, very quick to create these and place these down. They can be tied to assets. And when I interact with these digital sticky notes, I can attach a bunch of attributes to these. So contextual information, budget information. I can even set tasks in 3D and assign those out to people. One of my favorite features, though, is chat. And it's my favorite because that shows the power of the platform being a living project. This is a living floor plan. I can invite 50 people to this right now, give them certain roles and certain permissions in here, and we can actually start talking about the numerous projects we have in our space. We firmly believe that this is the floor plan solution for every building in the future. Of course, I'll say that because I'm the founder and that's the vision. But let's talk a little bit about real-time data, real-time information. We went pretty deep on security because security is the most important thing in a building, period. It's protecting the best asset, right? Which is humans, us. So going deep with cabling and also so cable design in regards to security, so access control and cameras and things of that nature, you have the ability to create a digital twin and get the specificity that you really need. But at the same time, we can pipe right into the live data, live information. So we can actually show the live feeds. And because this is so easily and readily shareable to anybody, you can share this out to first responders, you can share this out to on-site security teams. And now they don't just have a panel of a bunch of camera feeds, they know exactly where things are at, which will increase response time when on site. And that's just one example of the technology. But the ability to understand things in 3D and simplify these floor plans, but keep them live and ongoing is really the key. Being in 3D makes sense. We live in 3D, we eat, sleep, breathe in 3D. Why are we not communicating and ideating in 3D?
So I guess my first question, Timber, and I want to go around, is this a 3D model? Is this a digital twin? Is this a digital shadow? Like what do you call what we're looking at in your opinion?
Are you asking me?
Yeah, I want to go around. I want to start with you.
Yeah, I call this a digital twin. This is a digital twin of a building, and to me, it has to be in 3D because you need the XYZ metadata and coordinates from 3D to get specific, period. You cannot do this in 2D.
Got it. I want to go around next, but before I do, Timber, I want to come back to you and to the others so that you can kind of spool this up in the background. But I want to know the best experience, the best client experience you've had using this, because I want everybody to talk about their best client experience or their best experience using a digital twin. But Professor, can we go to you first? Like, what in your opinion, what are we looking at?
Sorry, finding the mic. So I think it is a version of a digital twin in a way that as long as folks are using this and turning a change in the physical world or some action in the physical world. So I'm kind of in sync with what Emmanuel was saying in terms of this interaction, important interaction from that comes to digital twin side to the physical. And would you like me to answer your homework question that you gave us?
Yes, very much, very much.
So I'll talk a little bit about, my experience in terms of this transitional research where we build up, these digital twins for HVAC and looking into creating these autonomous HVAC systems. And then we spun off a company that is around HVAC diagnostics and root cause analysis. And to me, that's an example of like how AI and digital twin can really work together. So in this environment where you have, sometimes we have 3D models, sometimes clients don't have 3D model, but they have a lot of sensor data. And the issue is that, there's all these control and other errors in the HVAC systems that that goes unnoticed. So you got to empower the, facility operators to make the right decisions so that they can minimize the energy waste that is happening under their hood. So that's kind of like a 30% of HVAC is these undiagnosed and unfixed errors and faults. So initially a research idea now turned into this company Lean FM and deployed, which I was surprised that in many of our clients, whether it's a newly commissioned building versus old building, there are these faults embedded that is not easy to notice. And it's because, you're getting these thousands and thousands of sensor data feeds, and there's no time for somebody to continually look at it. So you need an autonomous AI-based agent to continually analyze, but also adapt to the building's, operation conditions. For example, museums care about humidity. Hospitals care about air pressure and temperature. So you can't have like just a code, rule-based system to address those issues. Hence the power of digital twin, right? The digital twin kind of gives you the background through simulations, etc. And the AI combined, the system itself adapts to it without needing any user interface. So, users saying, this is what I like, here's my rule thresholds, none of those need to happen, right? So to me, that's really a rewarding experience, coming from research and being used and deployed and seeing the savings that the users receive.
Beautiful. I love it. Emmanuel, so thank you, Professor. Emmanuel, what were we looking at a moment ago from Timber, and in building on her approach, then give us an example of how you made it so for your own life.
Yeah, so first off, what Timber showed us is digital twin. Right, and the reason it makes it a twin is its ability to be able to simulate and to model all of the components and the assets that Timber was showing us, and this could then directly translate into an update of drawings of physical infrastructure. And I think the collaborative notes are probably one of the most useful feature on that twin, because using that, I can actually tell somebody exactly how that structure should be changed, modified, updated, versus having a static node placed there, or doing a site walkthrough, or then having perspectives and views. The whole objective of that twin is the ability to be able to integrate, simulate, model, and have those propagations done onto the physical world or the physical systems that could then be picked up by anybody to move forward with. In terms of use, I think the beauty of it, I probably will take a little bit from Timber and a little bit from Professor Burcu as well, is to say the relevancy of understanding how data fits in a 3D environment is absolutely critical. Like today, you could go to Amazon, Amazon's got that beautiful thing. How does it look in your space, right? And you can take it, you can put it there, and the vase looks good. But it really doesn't allow me to do much more than seeing how that vase looks in my space. What we look for is what are the changes that could be done to that physical environment so that it would be able to benefit the purpose it's being used for. For example, I take a data center example, right? Data centers are all about precision cooling, very different from commercial-based systems where you have a set point and you have a variation. Here we look for absolute precision point cooling that happens in. We care a lot about airflow, but we also care about humidity. Because anything that happens to those systems is going to out my servers. If my servers go out, I lose data, and data loss is something that we don't want at all. Now, in that, how are you going to understand flow of data and even or uneven temperature zones that exist on the flow plane of a data center if you don't have that modeled out on a twin in 3D? That's where the 3D modeling of it becomes absolutely critical. The second aspect of it, I will take it to my experience of overseeing and managing large campuses, and how do we design the concept of people flow or people in motion. When we look at spaces, one of the biggest things that we always try to understand is, why do people like to go to one particular spot in a corner or in the corridor of a building, but they hate to go to that same spot in a different building? It's at the end of the day, you can say, oh, it's just how it is. Well, it's not how it is. There are a lot of factors that will influence it: privacy, sunlight, accessibility, the ability to be able to have quiet conversations without being disturbed by someone else. All these factors unconsciously affect the human's choice to pick what they want. For example, next time anybody walks into a room, when you walk into a room, absolutely go in, and you are automatically aligned to sit in a particular spot on that room. If there are no name boards or plates there, even if nameplates are there, some people you'll notice they'll always change the position of where their name tags are on that table because they like to sit in a particular place. Now, it has little to do with who they're sitting next to, but more to do in terms of the space that they find themselves to be comfortable in. It's a natural tendency of a human to go and adjust themselves so that they feel a lot more comfortable where they're occupied. Some people like to sit in the middle. I mean, I'm sure if it's Ari, he probably like to sit at the head of the table. But someone like me would probably go down to the corner.
I just
sit
want to sit
somewhere
next
far
to
away.
you.
That's how humans are designed. Now, if I have to make that space more usable and more attractive, I have to cater for different types of human beings, which means I have to model behaviors. So everybody loves to pick up a portion and space in that room. Because for me, as coming from real estate, every square inch of that space has to be monetizable, right? I can't say, hey, I'll only monetize half of it and the rest I can throw away, right? I'm pretty sure Mark would get how important it is to monetize that. I can run those simulations on a twin, and I can conducively design a people flow, people motion, people entrances. So everybody has a unique aspect of that room which they would like to occupy too, thereby boosting occupancy and usability of that space. That's where twin comes in for people movement as well.
Let's stop and go to Mark then. Mark, please pick off on that. But first and foremost, what was Timber demonstrating in your mind? Was it a 3D model? Was it a twin? What was it?
It was a digital twin.
Okay.
And look, I went to the Realcomm conference a couple of weeks ago, and one of the things you saw all these sexy displays, right, of automation and building management systems with the application of AI to it. And one of the things that I noticed, and even though they had simple dashboards, to me, and if I was a facility management person and somebody comes up and says like this particular sensor's going bad or this HVAC unit's going bad, without understanding its location and the geography of it within the building, it's like so difficult to figure that out, right? And I think to the degree that we can make life easier for regular people who don't have to be technologically sophisticated, we're going to make sure that the systems get used more robustly and with more enthusiasm, right? One of the things that we're looking at using digital twins for is identifying and building OT cybersecurity, right? Where are all the unsecured IoT sensors in the building? Locate them, right? So that we can begin to monitor them more effectively. And finally, this is just from the standpoint of experience. I have compromised hearing. I wear hearing aids. One of the opportunities here is to study the acoustics of places. I walk into more buildings with terrible acoustics that, it makes it tough to be in these places. I mean, you may not even understand, like to Emmanuel's point, right? Maybe it could be too much sunlight coming through a window. Maybe it's the acoustics are really bad. And how can we design the space to be a more comfortable place to be in, right? In addition to all the other issues that we talked about, airflow and humidity and so forth. So I just think that there's a tremendous number of things that we can model through these systems. And it just has a great opportunity to deal with stuff much quicker, much more effectively with people who, don't need to be super technologically advanced to use the tool.
So with the time we have, and by the way, I'm flexible a little bit if people can go over, but can we go over 5 minutes because we're about 6 minutes out? Do people have an additional 5 minutes to add to their clock?
Yeah.
Okay, so good. That's good to know. So in the time we have left, I really want to have more interaction between the panelists. So I want to kind of prime the pump, but what does the future hold? What will accelerate adoption of these tools? Will it be a certain type of project, like a data center project, or will it be a certain type of scenario in terms of some macroeconomic condition, like God forbid, a world war? What will it be factors about ROI from the property developer standpoint? So I want to start with the professor. What does the future hold? And again, I want you guys to challenge each other. What does the future hold, and what do you agree and disagree with about what the other panelists said? Please.
Okay, so I hope that it's not going to be a drastic event that's going to make us shift stuff.
I hope so too. Yeah.
So I think so. There are a couple things. So one is to how easily we can generate and maintain the digital twins, and the example that Timber showed is a great example towards that, right? So we want to democratize generation and usage of these twins. That is one part of the equation, and that's a big bottleneck, and I'm glad to see that we have solutions towards it. The other part is what is the killer app, killer user case. Of course, Timbers is a killer app in generation, but in terms of decision making, Emmanuel mentioned, how do we create these controls where we could change things as I'm entering the room? In my mood, I can go towards the middle of the room today rather than the corner of the room, right? That requires more than physical digital twins, and also understanding humans in a privacy preserving way. So what would be the killer app that the owners are willing to pay? So I'm going to send it back to everybody else. What is a painful decision that you're facing that digital twins can solve, including, it can be any kind of diagnostics, prognosis, or control, predictive control approaches.
But before they answer though, is this graded on a standard or a curve scale? I know Mark's very competitive.
I'm used to all standards. Our
Okay.
students are excellent. I expect the same thing from this group.
Okay. Mark, you probably have a thought. Go, please.
Well, look, one of the things that I would be using this for as a developer and what I was doing most recently was we were planning districts, right? And I actually spent a lot of time with Google, who was having this very expensive tool. The only problem was they had to use it. It was more of a service and less of what Timber's product is showing. And it was going to cost hundreds of thousands of dollars to be able to lay out districts and maximize things like, your return on investment, but, try to maximize the views of the park and sun exposure and climate issues related to, how to improve things and make it as close to net zero as possible. And so we were able to have all these different algorithms that we were looking at, and we could model things, and we could kind of look at overlaying them and figure out what was the best approach, in the aggregate to these districts that we were designing. So I was not looking as granularly as the professor was for a particular building, but I'm kind of taking it to the other extreme on designing campuses and districts and things like that, and how buildings interact with each other.
So keep in mind, my question is, what's the roadmap? What's the future, and what are accelerants?
I think that, I think you're going to see cities even imagine these things, and other entities, companies laying out their campuses and thinking, along those lines, right? Other users who want to understand the aggregate contributions from, if I allow the city to get developed this way, here's what the results are on things like sewer and water and other uses.
Right. That kind of builds into one of the questions up on the screen, and anybody can answer it, but Mark, since you're on, so how can AI and digital twins drive innovation in industries, for example, in urban planning?
I think that was just what I was talking about, right? That, net zero is not just about developing one building, right? It's how about the interaction between buildings, and maybe encouraging people to walk between buildings, and maybe having green space and shaded areas where they can recreate, and instead of forcing people to get into cars, making a more walkable district so you never need to get in the car, or maybe it's a bikeable distance, right? So
Timber, Emmanuel, your thoughts, and anybody, please, this is a free-for-all.
Mm-hmm. Yeah, I have a few thoughts, if I can jump in. We're all talking about, AI, the future of AI. We believe the greenfield is going to be infrastructure and buildings next. And what we found in building AI, you need a data set. Every single one of us right now has been talking about a very single specific project, or we point to something that is useful. But the problem is these professionals in these projects are siloed. They come in, they do something, they get paid, and they walk away. And so you have to get everyone communicating in the same platform first. And then what you can do with that data is create additional AIs and algorithms to produce nanoseconds of a design of an entire security plan, for example, or evac plan, or space plan. But you have to have the data set. The data set doesn't exist today. I shouldn't say it doesn't exist. It does exist, but it exists in silos of groups that don't really share that data with each other. I mean, architects don't share their data with each other.
So can I paint a quick scenario and tell me if I'm in sci-fi or if I'm in 2025, which is a building that Mark designed is made use of your tool, is powered by one of Emmanuel's data centers, occupied by many of the professor's students and their various companies. So I'm trying to include everybody here. So, but there's a fire alarm. But it's because it's been twinned on your platform. There's a business rule that when there's a fire alarm, it automatically sends the floor plan to the first responders. It automatically puts up the best exit points, depending on where you are in the building, on some display in the hallway for all the people on each floor they're in, and somehow does heat mapping of occupancy based on time, like a time-based occupancy sensor that says, well, at time 0 when the alarm went off, we had everybody in their respective office or space, and then at time 10, 10 minutes, which might be the SLA, everybody's outside. Is that sci-fi or is that 2025?
It's not sci-fi. It's not 2025. We're talking like policy and other things that have to be approved to even send that kind of stuff out. So, which actually was going to answer your second question, in my opinion, on what's going to be the big event or what's going to be that use case that takes it to the next level.
Right.
Honestly, AI is growing very, very fast. There's more products being developed for buildings. And the problem with that is once it gets too big, too fast, guess who steps in and starts regulating it?
Yes,
the government.
Of course.
The government. So they're going to come in there and start regulating certain things and certain aspects, and they're going to be looking to a platform that everyone can use to not only be the platform from the beginning to an end of a project, but again, multiple professionals in it at the same time. So we're not far off from that, Ari.
Emmanuel, you've been very quiet or patient, one of the two.
Yeah, I was just soaking it all in. But to your comments, Ari, I'll start by two examples, right? And I'll underscore both the examples, just piggybacking a little bit of what Timber said. Twins are only successful if you have data to back them up. Data exists today, but it is not in a completely usable format that would allow us to start productizing it today, right? It's going to take some amount of time to clean, optimize, and refine that data so we could start using it in terms of where we want to go, right? And that's been a big challenge. The second part to it, with respect to it becoming a standard and being regulated, right? It's something that's highly debated today because you need someone who is a neutral third party to come in and say, hey, your digital twin is an actual replica of the physical world. For example, if I'm commissioning assets, right? Because commissioning is a big deal for me. So if I'm commissioning assets and if I can do digital commissioning, what is the guarantee that the digital commissioning will ensure the physical commissioning also succeeds? So having someone that comes in and saying, yep, you know what, looking at the model parameters, looking at how you set up, this is an actual replica, in fact, a real-time model of what the physical model is, and a digital commissioning of this asset will also mean a physical commissioning of the asset. So I can actually accelerate commissioning of physical assets. I can even accelerate retro commissioning of all the assets within a space, right? So that's a deep topic of discussion, and there are a lot of certifications and standard bodies that are getting into it where they want to use a twin for performing these activities. The second part of it is in terms of why AI and a twin is going to be important. Let's take a little bit on data centers. Everybody loves to see these big, huge announcements where someone comes and says, hey, I'm building a 500 megawatt data center. I'm building a gigawatt data center, or I'm building a data center campus. It all sounds really good. But what we don't understand is, how do you model the space within the data center for optimum use as to how the load should be propagated within? What do I mean by that? Look, big is beautiful. I get it. I love big things. But that being said, the challenge is, how much of the data are you willing to give up so that your privacy could be managed effectively? Your trade secrets could be managed effectively. So when I'm doing my data center design, and that is where now we're trying to get into the concept of, what do I really need to use to train my models? So the combination of hybrid data centers, where I'm going to have multiple types of servers and compute running inside it.
Emmanuel, we probably have like a 10-second on that.
Yep. And the last point that I'll probably say is the whole concept of motivating people to be able to understand where assets and where walkways and where parts should be placed. One concept I will leave this group with is, when I was designing large-scale campuses, we were talking about, how do you use inanimate objects at strategic locations to be able to motivate people movement and people interaction. That requires modeling and simulation, just like game design, yeah, that's what I would leave.
Very teasing. So, Professor, could you play the referee role, please, and maybe pick a question here that for whatever reason appeals to you on this topic, and then take a first response?
Okay, so just quickly, I think I'm going to combine the two questions out there. One is, how do you use the digital twin to airflow and operational efficiencies, right? You got to come with both of them has the question of visualizing and changing something in the physical world. So you can do that, and we have seen it. So in one of the first deployments we had with Lean FM was around casinos. So we went there and created digital twin and started analyzing data with AI, and realized that there's really a lot of air being blown into the casino. And we said, well, why is that? It's energy inefficiency. It doesn't work with your HVAC system. And then the response was, we wanted to make sure that the people are comfortable 24 hours a day in the casino. So there was a reason towards, putting a lot more air, even though it might be energy inefficiency and operational inefficiency in a certain way. So the digital twins can help you first figure out that there's a pattern here that you're not seeing before. Secondly, going back to Emmanuel's comments, is simulate. What if it was this way? What if it was that way? How would the occupants react, and what would be the energy efficiency loss? Right. So you got to understand, the decisions that you're making has multiple implications, and digital twins powered by AI would enable you to do that.
I mentioned, since you mentioned your company a few times, I put the link in there. I hope I put the right link, Professor, and also for
that is
Timber.
Correct. Yes, thank you.
I think that those are the closest thing we have to product discussions on this call. I mean, we're trying to stay kind of academic, but it provides good context. I have a closing thought, but I'm not opposed to anyone else having a closing thought. My simple closing thought is, first of all, I'm grateful and thank you for your time that you've carved out. I know you're very, very busy people, and so I appreciate it sincerely. Next month, on Friday, July 25th, we're planning to have another webinar, and some very interesting people that are going to talk about what are the decision points on investments into prop tech. I know everybody's always pursuing money and pursuing budgets and looking for ROI and break-even points. So the people on this call are from corporate and commercial and other places, are going to get us there. And I think it'll be also, like today, a very important, but frankly, a vital discussion that will help you with a range of decisions. So anyone else have a last word? Mark, Professor?
I'm just very excited with how things are moving along, and all the tools, the possibility of using them, and the potential is just tremendous. And it's happening so quickly. And I ask people to lean in and embrace it, and think about, how it can help you, how you can do a better job thinking about, especially these physical environments.
Well, knowing you, Mark, I think you practice what you preach. I think a lot of people that develop could learn a lot from your approach, which is what I consider holistic. I think that you don't rule things out by executive fiat or by emotion. You have a logical process, and I appreciate that with your approach. Anyone else have a you're welcome. Anyone else have a closing thought?
I just want to say something. Sometimes these terms, AI, digital twins, and everything comes as scary. So that's where universities can also come in play, that there are several, certificates and online courses that are available across the US, not just Carnegie Mellon, that helps in kind of bring a certain level of comfort around the technology.
We need that. We need more of that skilling. And it's not just for the 20-year-old, it's also for the 40-year-olds and sometimes 60-year-olds. There's a lot of decision makers that need that, whether it's a degree or a certification or even just a basic exposure, through a 2-hour webinar. So thank you. Anyone else? Emmanuel, Timber? Please.
Yeah, I was just going to say thanks. Thank you for having this. I appreciate it. Thank you, panel and questions and things. And we're here for you. We built this for all of you. And I think with us nerds in a cave, with what we've built and you professionals, we can get closer and faster to the solutions you all envision in your head. That's why we built what we built.
Fully agreed. And I do love your solution. Emmanuel, any thoughts?
No, thank you so much. I had a wonderful time. Great perspectives, and truly enjoyed the viewpoints on how we can make this real and take it to the next level.
Good. You should feel comfortable reaching out to each other. It would give me no greater joy than to cause that. And Sky, thank you for producing this. And to everyone, I wish you a safe weekend and pray for great outcomes.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Sure.